One of the most important concepts you will face during your journey through mathematics is being able to solve the equation. From the mighty equation, all branches of mathematics, from algebra to geometry to combinatorics, can be comprehended. Let's investigate the most fundamental aspect of mathematics, linear algebra, the home of the equations. How do we solve linear equations? How do we draw linear graphs? And how does it actually relate to other branches of mathematics? The anatomy of equations and expressions. Firstly, what is an algebraic expression and equation? Oftentimes, the two terms are used interchangeably, but this is inaccurate. An expression is a collection of operations, variables, coefficients, and constants, while an equation is a statement which relates two or more expressions together. The unknown values, represented by a letter or symbol, is known as a variable. For instance, the most widely used variable is x. Note that in the same equation, the same variables represent the same values. Coefficients are the numbers placed before variables, which denote the quantity which is being multiplied to the variables. For instance, in the expression 2x, 2 is the coefficient, which denotes that 2 is being multiplied to x. Constants are numbers that are fixed in value. Constants are given a degree of 0 as there is no variable present. Linear equations. Linear algebra is based around these simple concepts except with two or more variables, commonly denoted as x and y, per equation. Because there are now two or more variables present, we cannot find the variable values with only one equation. Thus, we are presented with two or more linear equations. Multiple equations which contain the same variables with the same unknown values are known as simultaneous equations. Let's solve an example together. Given the equations 10x plus y is 57 and 5x plus 2y is 39, how do we obtain both the x and y values? There are two methods. The first, known as elimination, ensures that we can eliminate one variable from the simultaneous equations to obtain the value of the other. We achieve this by setting the coefficients of one chosen variable to be the same in both equations. For instance, by setting the coefficient of y as 2, we can eliminate y. Note that in order for the process of elimination to work, the coefficients have to be set as the least common multiple, LCM, of the coefficients, or a multiple of the LCM. Nextly, we add or subtract one equation from another, depending on what operation can eliminate the chosen variable. In this case, we subtract to obtain 15x is 75, so x equals 5. By substituting this value, we can obtain that y equals 7. The other method is known as substitution. One equation is rearranged to isolate one of the variables before the equation is reduced such that the variable is represented in terms of the other variable. Then the value of the variable in the other equation is substituted in terms of the other variable to form a one-variable equation. By rearranging the first equation, we obtain that y is equal to negative 10x plus 57. Substituting this into the other equation, we obtain that 5x plus 2 times negative 10x plus 57 is equal to 39. Simplifying, negative 15x equals negative 75, so x equals 5. By using the first equation, y equals negative 50x plus 57, which is equal to 7. Drawing graphs of linear equations. The Cartesian plane is a two-dimensional grid that everyone has or will encounter in their lives. It is split into 4 sections with two infinitely long lines known as the x and y axis respectively. Any point on the Cartesian plane is represented with two numbers, its x-coordinate known as the abscissa and its y-coordinate known as the ordinate. A graph is a set of ordered points in the Cartesian plane that is defined by a function. A function is a simple relationship between a set of inputs and outputs, named the domain and the range values, respectively. To be a function, the input must match one output. An easy test to identify whether a relation is a function or not is to draw vertical lines through the graph of the function. If the vertical line crosses the function more than once, it is not considered a function. Today we are interested in linear functions, or straight lines. There are several aspects of linear functions to keep in mind. First is the gradient. The gradient is the slope of the line, found by taking any 2 points on the graph and dividing the distance between the ordinates by the difference between the abscissas. Note that you must subtract in the same direction. A positive gradient will have the graph going up and towards the right, while a negative will have the graph going down and towards the right. If the line is horizontal, the ordinates are the same. The gradient will be 0. While if the line is vertical, the abscissas are the same. The gradient is undefined. To learn more, view our video on the divide by 0 error. The y-intercept is the point at which the line crosses the y-axis, written in the form 0, y, while the x-intercept is the point at which the line crosses the x-axis, written in the form x, 0. The most common method to write linear functions is in the form y is equal to mx plus c, where x and y represents the x and y coordinates respectively, m represents the gradient, and c represents the y value of the y-intercept. The slope-intercept form of the linear function is one of the most easiest forms of linear equations to use, and we will primarily focus on using it for this video. To graph a linear function, we need to first plot some points that we can connect. The minimum recommended points on an exam is 5, and we can find the x and y values of the points by plugging them into the linear equation. A handy way of representing this data is by using a table. Given the equation y is equal to 3x plus 2, we will plot the following points. Notice that when plotting the points on the Cartesian plane, we will represent them as crosses instead of dots to avoid confusion later. After plotting the first 5 points, we will join them carefully by using a ruler. Unless a question specifically asks for a set of the domain or range values, draw the straight line to cover a large portion of the Cartesian plane. The graph y is equal to negative 2x plus 4 is different from the previous example, in that this time the gradient is negative. By plotting 5 more points and connecting them, we can obtain a second linear graph. The graph y is equal to 3 has a gradient of 0, meaning that no matter what value of x we plug in, the y value will always be 3. Represented as a graph, it is a horizontal line. The equation x equals 5 does not follow the slope-intercept form that we are focused on, and it represents a vertical line. This time, no matter what the y value of the point is, the x value will be 5. Solving for linear equations. Sometimes, rather than being given a linear equation to graph, we are asked to determine the equation of a graph. In all of the following examples, we will represent our final answer in slope-intercept form. From the given graph, how do you obtain an equation? Well, firstly, we need to obtain the important features of the graph, such as its gradient and its y-intercept. By finding these values, we can find the m and c of our linear equation. Finding the gradient m requires the identification of 2 points on the line. Afterwards, you find the difference between the ordinates and divide it by finding the difference between the abscissas, subtracting in the same direction. Then, replace m with this value to obtain y is equal to negative 2x plus c. To find c, pick another point on the line with known coordinates. Substitute the x and y in the equation with the respective coordinates and solve to find for c. In this example, we can obtain y is equal to negative 2x minus 1. Linear inequalities. An inequality is like an equation except the equal sign is replaced with one of 4 symbols. less than, greater than, less than or equal to, and greater than or equal to. To solve an inequality, like in an equation, we have to isolate the variable x. For instance, in 3x plus 5 is greater than 8. We can rearrange to obtain 3x is greater than 3, so x is greater than 1. But if the coefficient of x is negative, reducing the term results in the flipping of the inequality sign. For instance, if negative 3x plus 5 is greater than 8, then negative 3x is greater than 3, and x is less than negative 1. We graph simple inequalities on a number line by drawing a circle around the number that we obtain and drawing an arrow that represents the solutions for x. If the number is included in the set of solutions, we fill in the circle, while if the number is excluded, we do not. A linear inequality is like a linear equation, except with an inequality sign instead of an equal sign. For instance, y is less than or greater than or equal to 3x plus 2. We graph a linear inequality on the Cartesian plane. To graph the inequality, first solve it like how you would solve a linear equation and graph it. The line serves as a border between the set of points that follow the inequality and the points that do not. Determining which side is which requires the sampling of a point. Pick any point with simple coordinates and plug the x and y values into the inequality. If the inequality holds, the side containing the point is the solution set, while the opposite is true if the inequality does not hold. Shade in the side containing the solutions. Lastly, determine if the points on the line are solutions to the inequality or not. If they are solutions, keep the line solid, while if they are not solutions, ensure that the line is dotted. Conclusion. Mathematics is infuriatingly simple if understood and applied correctly, and linear algebra is the most infuriatingly simple and critical aspect of math.